Hey everyone, let's talk about simplifying radical expressions. So expressions that contain radicals. All right, we've got three categories. So first of all, we're going to practice simplifying radicals that have quotients and products. So we're talking about expressions such as the square root of 72 divided by 9. Now what we're going to do is we're going to use Desmos to help us know if we're going in the right direction. So apparently the square root of 72 divided by 9 is equal to 0.9428, bunch of decimals. All right, so we know it's a little bit less than 1. Okay, so what we want to try to do is express it in a more simple but still exact format without having to use that decimal. All right, so here's how it goes. To simplify a radical expression, you want to basically factor that radical in a way that will contain one of the factors being a perfect square. For example, the square root of 72, well, that can be the square root of, I don't know, well, the square root of 72 times 1, or the square root of 9 times the square root of 8, right? What we want to try to do is we want to try to find the largest perfect square, though. So the largest perfect square that will fit into the square root of 72 is the square root of 36. So we're going to break it up into the square root of 36, root 36 times root 2. And I'm going to enter that into Desmos just to make sure it has the same value, and it does. All right, now root 36 is easy to simplify because it's a perfect square. Root 36 is equal to 6. And the square root of 2 can't be simplified anymore. It's an irrational number. So we've got 6 root 2 over 9, which actually, when you really think about it, 6/9 is equal to 2/3. So we're going to say that this is equal to 2 square roots of 2 all divided by, well, all divided by 3. And we see we have the same expression. So that's the simplest way to write the root 72 over 9. Okay? Moving on along. What if I have addition and subtraction? Well, that skill of simplifying a radical carries over to whatever type of expressions we have. So if I have negative 10 root 192 minus the square root of 27, so that's an odd looking number. I check its value. It's worth about negative 143.76, bunch of decimals. All right, so I'm going to start breaking up my radicals. So the largest perfect square that'll fit into 192 is 64. So I break it up into the square root of 64 times the square root of 3. Square root of 27, I can break it up into square root of 9 times the square root of 3. All right, this is convenient because both of these have a root 3. That means that they're going to end up being, they are like terms. So let's clean this up a little bit. The square root of 64 is 8. All right, and the square root of 9 is 3. So, and I keep entering my expressions into Desmos to make sure that I'm still at negative 143.76. All right, next thing I'm going to do is I'm going to combine my negative 10 multiplied by my 8. That's negative 80. So I got negative 80 square root of 3 minus 3 square root of 3. When I combine those are like terms. It's kind of like saying negative 80x minus 3x. You're going to combine the coefficients. So let's combine the coefficients. Negative 80 minus 3 is negative 83. So negative 83 roots of 3 are equal to the original expression. Again, if you know how to simplify a radical, it makes a world of a difference. All right, so always factor it, finding the largest perfect square factors. Remember your perfect squares: 1, 4, 9, 16, 25, etc. All right, here's a couple more. What if I've got binomial expressions, all right, that contain radicals? So 6 plus square root of 5 times 6 minus the square root of 5. All right, now in the Desmos file, I demonstrate this with FOIL. Some of you guys like to use the box. All right, so let's say 6 plus the square root of 5 times 6 minus the square root of 5. Well, 6 squared is easy. That's 36, right? Square root of 5 times negative square root of 5, that's going to give me negative 5. You can think of it as negative square root of 25, right? Which is negative 5. All right. What you want to think of is a radical times a radical really cancels itself out when it's that same expression underneath. So that's negative 5. And then this is going to give me 6 roots of 5. And this is going to give me negative 6 roots of 5, which in turn are going to cancel out. So really, I've got 36 minus 5, which gives me 31. So I could have seen from the very beginning that this was going to have a value of 31. Last, I can look at my final example, and again, I can use a box or FOIL to multiply this out. For this one, I end up having 3 plus 2 roots of 30 plus 10. I can really only combine my like terms, which are integers, so I get 13 plus 2 root 30. And that's as simple as I can get it because there's no large perfect square that'll fit into the square root of 30.